Ralph has stated the problem quite clearly and some possible solutions. I think Cathy is now going to explore the solution space a little bit more. So Cathy Almond from ISC.
So hello, can you hear me? I'm going to follow on from Ralph's excellent analysis, which the first time I heard it I was very, very excited because it was confirming what we had been seeing but had not had the scope to do the analysis for. I'm going to start with summarising a little bit about the history of protecting DNS servers and then move on to, in more detail, the kind of work that we're experimenting with now with tools for recursive servers for dealing with this kind of problem. So historically, there are some well-known problems for DNS servers. The reflection attacks, the objective being to send small queries with a spoofed source address so that the large response is then targeting your sender. The response to that has been things like response rate limiting, sometimes inbound filtering on firewalls and similar. But this is an old problem, and the focus has been on the authoritative servers rather than on recursive servers. Another problem arose, and which was mitigated, was how to block domains that you don't want your clients to be going to. And they may be malicious or there may be political reasons for it. And for that, the initial response, or what people were doing, were developing in their recursive servers, making themselves authoritative for the domains that they didn't want their clients to access. And from that, we came to response policy zones, DNS RPZ, which I think is available for a number of DNS software solutions these days in the form of patches, and which is built into Bind. The beauty of the DNS RPZ stuff is that you can update the zones dynamically, and you can subscribe to feeds and have somebody else do the provisioning of what's bad and what's good for you, much like anti-spam. Another thing that has been seen, although less frequently these days, is what happens if, due to an accident of management of the servers or availability of that space in the internet, a popular domain goes down and suddenly all the clients in the world are trying to get to that domain, and that domain servers are not responding. That does cause problems similar to the ones that we're going to talk about later, with an increase in the recursive load on recursive servers, because you just get such a backlog of clients who are waiting for answers, and you build that into your resources. That I haven't seen for quite a while now, and I think that's probably due to better provisioning by the major providers, Anycast techniques, content distribution networks. But the outcome for recursive servers is pretty similar to the problems that we're seeing recently. So the newer ones that we're seeing, and over the last year or so, unusual patterns of client queries. We've seen, I think Greg posted on the IRC channel, there was an accident, purely accidental bit of development by TuneIn Internet Radio, who decided to use DNS queries as a mechanism for keep alive for their connections. And so they would send these random queries that wouldn't necessarily, well, wouldn't get answers, they'd get NX domains back, but that caused a load on the server just in dealing with them. There are the Chrome random probing queries, but not to the extent of the TuneIn, and they're still going on, but I don't believe that they cause significant problems. But what happens is that you have an increase in NX domain responses, and what most recursive servers do is they cache NX domain, but all of these are unique. So you end up with a creeping increase in cached NX domain in your cache that you need to manage. So you end up building up that resource and using more memory. The mitigation for that one is just don't store the negative responses for as long as they say you want to store them. And in Bind we do that using max ncache TTL. So I would recommend reducing that if you're seeing this kind of traffic. But that's a different problem again. These are queries that are being answered, but answered negatively, but rather a lot of them. So moving on to the new stuff, and I don't think that I need to go through this in a huge amount of detail because that's just been covered. But the critical features are that the queries are unique. Each query is different. The clients are different as well. They come from a variety of clients. There won't be very many queries from each client necessarily, so you can't home in on the client as being the culprit very easily. What happens is that the server that is being sent the queries eventually stops responding or only responds sporadically. And you end up with a build-up of the recursive client context and other internal contexts, all the things that you need to do to manage queries from clients and the fact that your server is also doing a series of queries. Ooh. Okay. And also that your server is having to manage the on-bound queries that it's making iteratively to other servers on the internet. And the problem is transient. The problem, you'll see that it is queries for one domain or 2 or 3 domains for a period, but it's a moving target. And the fact that it's a moving target also makes it quite difficult to handle. I too have a very similar picture. We think that the majority of these, or the evidence for the majority of these, is that they are coming from home gateways, so from badly configured or badly managed CP devices in home network. And they are proxying queries from clients on the internet and then sending them to ISPs resolvers. So the target is not actually the recursive server, but the recursive server is feeling the impact of them. Yeah, moving on from that one. I think that's, unless there's any questions on that one afterwards, I think it's fairly well understood. The issue is that the authoritative servers who are the target of this traffic are just not responding. The result is that the recursive client contexts, that's the information that you have to maintain when you're running a recursive server, because you have to know who is entitled to a response, having queried you, but then you have to go off and get the answer for them. So there's one place that you've got to maintain a bit of state. The other place where you maintain state is the management of the on-bound queries. So you have to track who you sent a query to get an answer back and whether they've responded or not, so that you can time them out eventually and try another server. So all of those things take up resources internally in recursive servers, and eventually those resources can be exhausted or stretched to the limit. So there needs to be a way of managing that successfully. We think this is a wake-up call. We think it's a wake-up call because what we're seeing at the moment is accidental damage to recursive servers, in other words, collateral damage. I quite believe that the senders of the query traffic intended for the authoritative servers have no idea of the impact that it's having on some large resolvers as a result of what they're doing. But this is something that we need to be able to manage better and do something about now before the light dawns, as it were. So there are lots of mitigation approaches for this, and some of them were covered in the previous presentation. The traffic patterns that are being seen aren't just, are not just affecting bind, and not just affecting nominum servers, they're affecting all recursive servers out there. Oh, I believe they're affecting all recursive servers out there, I can't believe they're not. There have been some practical manual mitigations, and I'm going to run through those. There are some solutions that are specific or could be employed by all DNS servers, and there are some that we're experimenting with now in Bind, and I'd very much like your feedback on those. They're experimental. We've not put them out publicly yet because we're a little bit nervous about introducing changes that might have knock-on effects. But they're available for anyone who would like to experiment and give us some feedback. So anyway, moving on, mitigation approaches. The first one, and this is usually the first thing that we say to anyone coming to us saying, we have this problem, and this is the traffic, and this is the build-up of the recursive client contexts. We run through three things. Is your recursive server an open resolver? As an ISP, are you actually running an open resolver? Because that generally is thought to be a bad thing unless you have some way of managing the traffic that is being sent to you effectively. Most of them aren't, some of them are, for all sorts of reasons. The most commonly seen one is the open client CP devices. Now, if you have open client CP devices, that means that the traffic coming to those CP devices, the queries that are then being proxied to your recursive server, those queries will be coming in through your network. And the question that we ask is, should there be queries to port 53 on the WAN port that you've given your clients? If there shouldn't be, why not block them? The answer to that has varied, but most of the tech people say, oh yes, this is a good idea, and most of the management people say, hang on a moment, but. So there's an element of negotiation going on there, but that is a very clear way of blocking this traffic. Just don't let the queries go through to the CP devices, and then they won't come and hit your recursive server. Within that, there have also been seen situations where you have business users that run their own servers that then forward to the nice big caching recursive server that an ISP runs. And in that case, you can't just cut them off, but you can go and work with the administrators of that server to fix the fact that it's an open resolver. I have heard, but I have not seen with my own eyes, that there are some compromised clients also sourcing this traffic. I remain unconvinced, but at the same time, I think it's only a matter of time. So that's something to bear in mind in dealing with that type of traffic too. So those are practical ones that you can do. External to the DNS server itself, that's within the network infrastructure. The next thing that we have recommended and have seen done in various forms is, and it's whack-a-mole time. I already mentioned that the domains that are being queried are a moving target. You can spot the traffic attack fairly easily if you have access to the build-up of recursive client contexts, because the problem that occurs is when there is enough of this traffic coming into a recursive server, then the authoritative servers stop responding, so then you get a backlog, and the backlog is the problem, but the backlog is also the source of good information about which domains being queried are the ones that are a problem. So it's possible to do this manually, look at or monitor the recursive context backlog, and then make yourself authoritative for the domains that are not being answered, with the result that you then respond very, very quickly NX domain rather than serve fail, or not respond at all for those queries. There is a problem with that one. Well, there are good things and bad things. One is that you're preventing potentially valid queries to the domain for a period, but then the server wasn't responding anyway. Remember that you have a domain that's under attack. The idea is to try and limit the attack to the domain, but you don't want to cut it off entirely because one day the attack will cease. The other problem is that you can end up with false positives. Think about a very popular domain that is temporarily unavailable, or is that there's a blip somewhere in the etherwebs, and there's a temporary little tiny build-up for something like facebook.com. You don't want to cut off things that are not being attacked accidentally at the same time as the ones which are. So there is that problem as well, and you might need whitelists. And you also very definitely need to, if you're implementing this approach, do it for a period, but then you need to switch it off again when the attack stopped, so that the traffic that should go through, the legitimate traffic, could go through and is answered. You can also do this with DNS RPZ. You can do RPZ, I should say, over here in this. I have a habit. I mostly talk to Americans. So DNS RPZ, you can manage yourself, and it could be an easy way of implementing than defining your own authoritative zones. So that's the same solution but done a different way. And I think there are some postings on either, no, I think they're on, I think they might have been on DNSOARC mailing list. Certainly some possible solutions to this and ways of configuring this with DNS RPZ domains. So now moving on to what we have done and tried. The first thing we thought about was, okay, we have a server which has stopped responding because it's under attack. We do want to carry on sending queries to it. We certainly want to carry on sending queries to it when the attack has finished. But while it's not responding, there is no point in sending it queries. We're not going to get answers, so we're not going to be able to satisfy the genuine clients coming along. And we're causing ourselves trouble by trying this. I've included this for completeness. This is something that we tried initially because it was easy to do, as in it fitted nicely within the way that our code structure and our internal contexts were set up. What we did is we set a timer for each server per zone, and then we counted how many times, do I mean a timer, I mean a counter. We counted how many times the server stopped responding. If it exceeded the threshold within the time period, then we would say, okay, well, we're not going to send any more queries to this for that time period. When the end of the period was reached, then we'd start sending queries again. We added a little tweak to it, which was if the next response is also a timeout, then we don't have to count all the way through again. We know that it's still not responding, so we won't send any more to it for the timeout period. What you actually get is very cyclical behaviour, because if you put the timer on and then take it off again, within the timer period you're going to get another bunch of queries being sent. But for a server that is just not responding full stop, it mostly works. For a server that responds once in a blue moon, it doesn't work, because you end up resetting the hold down timer for each time you get a good response and starting to count again. So for this kind of attack traffic versus a genuine outage, it was not effective. So we kept it in and then subsequently have replaced it with something better, which is, and this was an idea that was put to us having presented the problem and some of the things we were thinking about at the last IETF meeting in Toronto. Rate limiting fetches per server. Fetches is the context that is to do with the iteration versus the context which is to do with the client. You can rate limit the fetches per server and say, okay, well, I will allow my server to only hold so many outstanding iterative queries to this server, and after that I will accept no more and serve fail them. We went one step further. We made it possible to configure the upper limit, but then, again, based on suggestions, we thought, well, actually, it might be possible to move this dynamically depending on the kind of behaviour that we're seeing. So there is another tweak to it, and if the server is not responding and has reached the upper limit will gradually go down until the point where the server starts responding again. When the server starts responding again, it will gradually move up. So it's already built in the business of it not responding and then recovering, and then we start to send queries to it again. I have the details on the of the parameters if anybody wants them afterwards, but I don't propose to go through them now. It's pretty effective for servers that are queried a lot. It's also doesn't impact servers that are only queried infrequently, because you're never going to reach the point of the threshold. And it's not going to impact servers that respond immediately, because you'll never have a build-up of backlog of fetches. This is the one that we're the most excited about, and this is the one that we have just coded to replace the original hold-down timer. The other thing that we did at the same time as the hold-down timer, and which we've left in, and we're dithering about whether to keep or not, is a limit on fetches per zone. And this is the concept where you're looking at what domain is being queried, not the query itself, but the cut above it. So where the zone is, if that zone is being persistently queried for stuff within zone too frequently, then we'll cap it. That was the approach that proved to be effective versus the hold-down timer for the type of authoritative attack traffic that we were seeing. But we think the fetches per server will be more effective in the long term. We tried, we have actually changed this, because in passing we discovered that, or we didn't discover, we knew, we had never really dealt with this. We have a limit in bind, which is a hard limit on the recursive clients, and the default is 1,000. If you go above 1,000, in other words, if you manually manage this, you get a soft limit. And the soft limit is much nicer than the hard limit. The hard limit, if you reach it and you get another client query and you've got no room for it, you just don't answer, end of story. So you end up with non-responsive behaviour. With the soft limit, what the server will do is it will accept the new query, but it will time out prematurely the oldest waiting query. What we've done is we have changed the default behaviour so you will always get a soft limit. It's an okay solution for a server that doesn't get many queries. For a server that gets a lot of queries and which is suffering this kind of traffic attack, you can make the number for the hard limit very, very high. But if you make it too high, then eventually you run out of other internal resources. If you make it low enough so that you don't run out of other internal resources, such as sockets and that kind of thing, then you may get into the situation where there are so many queries coming through that you're actually timing out legitimate queries before they can be answered, before the answers come back from the servers. So yes, it is a good thing to do. No, it's not necessarily a final answer solution. The last one I'm putting in is it was an idea. I was never totally convinced that it was going to work or going to fly, but the thought was that the traffic and the backlog we were seeing were similar to TCP SYN attacks, so why not try one of the approaches for a TCP SYN flood attack, which is that you don't drop the oldest, you actually randomly drop something in the middle. Yes, okay. It's in there because it's something we're still experimenting with. We may well take it away again. We have some more ideas. We have ideas about instead of opening multiple sockets to a server with all the queries, actually we will single thread them to a new server until it's proven that it actually responds, and then it's a good one. If it's a good one, yes, then we'll talk to it normally. If we don't know, we won't talk to it normally until we know that it's good. Yeah, I'm not sure that we'll do that, but it was an interesting thought. Something that we do want to do, and we haven't done yet, but are in the pipeline, are whitelists. Because with all of this automated stuff, there are always corner cases and exceptions. So the things that we want to be able to do are say, set different values for fetches per zone, fetches per server, or possibly disable certain behaviour for certain servers or for certain zones. Serve fail cache, we don't have that at the moment, but it's something that we've been thinking about for a long time, and again has just this morning I see been coded up, so is likely to become part of the mitigation strategies package. The reason for this is if you don't respond to a client that is sending this kind of traffic that you don't want, or if you respond serve fail, chances are, or in most cases, it will send the same query again. So you end up going through the same loop of, well, here's another one of these. If you've cached the serve fail that you sent back the first time, then you can respond quickly and send it on its way more effectively and efficiently. And we'd like to improve the reporting and statistics. There is reporting and statistics in what we've done so far, but it's a bit ad hoc and done, unsurprisingly, the easiest way we could do while we worked on the actual code to do the thing that we wanted it to do. Okay, so we're almost at the question. Well, we are at the questions part. Any other ideas? Any other thoughts? I would offer that tuning is a black art. I don't think that there is a hard and fast solution to this kind of traffic. I think that it's a many-faceted way of dealing with it. And I think I used the whack-a-mole analogy earlier. Different forms of traffic patterns will emerge and different ways of dealing with them will have to be evolved. And at the same time, we need to make sure that we don't make matters worse in other places. In other words, that we're doing a good thing, but not at the same time introducing a bad thing that will cause impact to other types of traffic inadvertently. And the other thing that we haven't really dealt with yet is TCP. And yes, I'm aware that the authoritative servers implementing response rate limiting and using the slip factor will be sending back in some cases a response with the truncate bit set, which then causes the query to be retried over TCP. And the stuff that we have done has not yet dealt with TCP. So, okay. Over to you guys. Any questions, any ideas, any thoughts?
Jim Reid from RTFM. Cathy, I'm a little bit confused. All these sort of additional protective measures that you're proposing or suggesting here, how do they really differ in principle from what's going on already in the name servers with round-trip time calculations? So the name servers are already doing that. When they're querying resolving servers, they're remembering how quickly the authoritative servers are responding. And if an authoritative server is not responding, they tend not to query that for a while. So how does that existing pattern of behaviour differ from what you're suggesting as these new experimental techniques?
It supplements it. If you think about launching an attack on a domain, the queries that you are launching are going to attack all of that domain's name servers. So eventually you get into the situation where all of the name servers are responding sporadically, in which case you've got a round-trip time for them. It's a very long round-trip time for them, but those are the servers that you need to query. There are no other servers. Therefore, you have to query those servers. Therefore, you end up with a build-up in client backlog resources and iterative query resources.
Yep.
And this is aiming to deal with that, because you can't solve the problem that the server just isn't responding very much.
Okay. One other question is, I think we probably need a document about this. You were talking earlier on about the issue of the engineers saying, let's, for example, switch off inbound port 53. And management people are going, don't know about that so much. I think it would be very helpful in those situations for the techies to be able to say, look, there's this document, maybe it's coming from the ITF, maybe it's coming from OARC, or somewhere else. But if we have something that documents some ideas about best practices or some recommended techniques for mitigating these kinds of attacks, then at least there's something to be pointed to that says this is why you should do this, and that other organisations are doing it. I've wondered if you've given any thought to producing such a document or finding a suitable outlet for actually making it public.
We haven't thought about, although it's a good suggestion, putting a best practices document up somewhere other than our own knowledge base, but we have got the words because we have said those words so many times to so many different people. We have the words that we can put out as this is what we recommend you do and how you run your services for this eventuality. Yes.
Okay, thanks.
Good suggestion, thank you.
Hi, David Friedman, Clarinet. Just a few points. Firstly, just to follow up from Jim there, the issue of blocking inbound 53, we've been doing it for many years. Business case was very simple. We just didn't break anything. And we told everybody we were not going to break everything. And that was, everyone was happy. I think my main question was actually about these clients. Assuming you're not an open resolver yourself, what's the issue with blacklisting the clients?
I refer you to my T-shirt.
I see.
It's a level 8 and a level 9 problem. The management of the organisations, some organisations will say you can't just block the clients because mumble, lose money, lose client confidence, we promise this, blah, 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 blah. So, yes, it has been suggested as a way to go. Blocking port 53, I think, is easier than just blocking the client. But you end up having to go through, organisations end up having to jump through so many hoops. We can only recommend, we can't force an organisation to do something different from what we suggest.
I think if these organisations had well-written and enforceable, acceptable use policies, this would possibly be less of an issue for management. Right.
Possibly, yeah. Fair enough.
Neil O'Reilly. First off, an absolute +1 or +10 or something to that last remark from Dave. But what occurs to me is that although automatic tuning is very nice, it's the kind of thing that can go unstable. In the same way that you get howled around in an auditorium or paging flapping in a page memory management system or route flapping or whatever. And I just hope that the stability of the tuning process is one of the things that's on your agenda.
I hope so too. There are parameters for tuning it. It works on counting or observing the last 100 queries that went through, and then looking at the responsiveness rate, and then according to thresholds, either tweaking up or tweaking down the limit. So theoretically, it shouldn't flap.
There may be combinations of those parameters which may give perverse behaviour, and it may be important. A long time ago, when I was a research student, I did stuff in stability theory, and if you move the coefficients together in wrong ways, you can land in a wrong part of the space.
You're the sort of person that I might want to tempt to try some of this, because you can actually tune all of these parameters.
Let's talk later.
It'd be interesting to know what are the best settings.
Right.
Okay, any other questions? Okay, thank you very much, Cathy.
Okay.